Hey guys, I hope you are having a very good day. My name is Siva Prasad, and as you know, for quite a few days, I have been bringing you science and technology, current affairs, things that are in the news through these short videos where we try to comprehensively cover important developments in the field of science and technology. So today, I am going to take up Google's quantum supremacy. This was in the news for a long period of time. This was hugely debated. A lot of articles were written, including a lot of op-ed articles talking about the future of quantum computation. And remember, quantum computers have been often called out as the revolution of the decade or something that has been in the pipeline, right? And this Google's quantum supremacy, okay, as it calls, it establishes certain things. So we will try to understand what exactly does it mean to achieve quantum supremacy. What are these quantum computers? What makes quantum computers better than the normal computers that we are using right now? Okay, we will be using the term classical computers to be referring to that particular computer that you and I are using. Okay, so including all the supercomputers that we have, so they are also classical computers. Okay, so this will be presented by me, Siva Prasad. So if you want to stay updated, make sure you are subscribing to this Unacademy Current Affairs channel. So let me dwell directly into the news. What exactly does it mean to achieve quantum supremacy? So there is this Google's quantum computer. It is called as Sycamore. Okay, just try to remember the name. It has claimed quantum supremacy. What does this mean? What did this supercomputer exactly do? It solved a problem in 200 seconds. What would have taken a normal supercomputer 10,000s of years? So that means there is a problem. There's a mathematical problem, imagine. Right? So it would take a normal supercomputer that we have, the fastest of the supercomputer that we have on Earth, it would take it 10,000 years to solve that particular problem. But this quantum computer, it has solved the same problem in just 200 seconds. Can you imagine what this means? If I have to convert it into seconds, it is 10,000 multiplied by 365 days in a year, 24 hours in a day, then 60 minutes per hour. This is the amount of seconds it would take a normal computer to solve this problem. But Sycamore has solved this problem in just 200 seconds. So this achievement is what we are calling or attributing as the quantum supremacy. Alright? So that's what. So by doing this, Google has established quantum supremacy. Okay, the name of the the quantum computer, as I told you, is Sycamore. What exactly was the problem it was trying to solve? It was trying to solve, are random numbers generated by computers truly random? For example, in many programming languages, it could be C, C++, or let me take a very simple example. In Excel, you might have used this function, right, is equal to RAND bracket bracket. If you see what does this do, this function, it throws out random numbers, right? For example, 0.13, 0.12, like this, it would spit out random numbers, right? So that's what this actually does. So what we are trying to verify is when I use such functions, when I ask the computer to generate random numbers, is it truly generating random numbers, or is there some kind of pattern to this? Okay, so this is the question that I am trying to address. So this question, to answer this question, it would have taken 10,000 years for a normal computer, but it has taken only 200 seconds for the quantum computer Sycamore to solve this problem. Alright? Okay. So what do you mean by complex algorithms? Remember, for example, if I ask you 9 into 3, you can quickly give me an answer, it is 27. Now I start to increase the complexity. Okay. So as you can see, as the figures keep on increasing, it will take you more amount of time to solve the problem. So that is the same thing with the normal computers as well. Okay, so that's the reason you see you are able to do something at an exponentially faster rate using a quantum computer. What you have established, this is called as quantum supremacy. Okay, now an interesting question might crop up in your mind: how exactly was Google or Sycamore able to do this? What makes quantum computers so special? So let's try to understand some background behind this, right? For understanding quantum computers, I have to talk to you a little bit about a field or a subfield of physics. It is called as quantum mechanics or quantum physics. What happens is, at a smaller scale, when we go to the atomic level, right? When you go to the nano level, etc., you see the classical mechanics it feels. Classical mechanics, matlab the traditional physics that we know. the usual laws of physics that are applicable in this macro world that you and me are familiar with. That laws of physics, it completely fails. There's a different law of physics that is required to understand things taking place at the subatomic level. Electrons are behaving in a weird manner. To understand that, the normal physics is just not enough. We need something called as quantum physics. Okay? Why? Because physics is fundamentally different at the quantum level. Okay? So when we go dwell deeper at the subatomic level, physics is fundamentally different. Okay, so that's the reason we require a new kind of mechanics to understand. So that's why we decided we should have something called as quantum mechanics. Phenomena unthinkable in the normal world would seem possible in the quantum. Things that are counterintuitive, you will be like, how is this even happening? So those kind of things are also possible in the quantum world. For example, I will give you an example of superposition. These things are unimaginable in the real world, but it is totally possible in the quantum world. For example, or I can give you one more example of something called as tunneling. Okay, let me draw a very simple example, a parallel, so that you are able to appreciate these terms. Okay, let's assume there is this moon, and let's say this is you. Okay, you have an energy of, let's say, 10 joules, right? But then for climbing this mountain, it will consume 20 joules, right? So that means you should have 20 joules for you to able to cross the mountain, but you only have 10 joules. So if I ask you, what is the probability that I will find you on this side of the mountain, you will tell me that the probability is zero. Why? Because you simply do not have the energy to cross this energy barrier. Okay, to cross this mountain, you simply do not have this kind of energy. Okay, now in this case, let's do one small thing. Let's try to replace you, the human being, with an electron. Okay, and let's try to replace this mountain with something called as potential barrier. Okay, so if I again ask you, what is the probability, right, that you will find the electron on this side? Remember, electron requires this much amount of energy to cross over the potential barrier and to be found on the other side. The electron simply does not have the energy to cross over and appear this side. But if I still ask you, what is the probability that I will find the electron on this side of the potential barrier? This time the probability will not be equal to 0, right? It will not be equal to 0. There is some amount of probability that you will still be able to see the electron on the other side of the potential barrier. Okay, so in quantum mechanics we believe that it simply tunnels through to the other side. Okay, this is called as tunneling. Now this might be quite confusing to you. You might actually ask me, so this is a physical object, this is a physical object, how does all these occur? So as I told you, these are things that only happen at the quantum level. The behavior of the electron is so strange that it is very difficult for us to understand how could these objects be very stable. Right, while we talk about quantum mechanics, if I ask you, where is the electron, you you will not be able to tell me where exactly is the electron. You will say, in this particular area, with an 89% probability, I can tell you, you will find electrons in it. Okay, electrons behave in mysterious ways. The quantum particles, they behave in mysterious ways at the quantum level. So that's the reason when we go deeper and deeper, it is important for us to understand or come up with a new set of physics, new set of principles, new set of equations to try to understand the strange behavior at the quantum level. Okay, so let's do a quick comparison between the computers that we are using right now, which is called as classical computers, versus the quantum computers. Okay, so as you can see, I told you it took Sycamore only 200 seconds. What would have taken 10,000 years for a normal computer? So as you can see, this is exponentially faster. Okay, it's not 2 times faster, it's not 3 times faster. The word we use is, we say that the quantum computers, they are exponentially faster than the classical computers. Okay, they will have enhanced storage capabilities, they will have enhanced computational capability. See, they are able to solve something in 200 seconds. So that means their computational capability is far superior to that of the normal computers. Okay, and remember, in the normal classical computers, we use something called as classical bits. All the data that you have, it is stored in 1 or 0. So I can simply say that in a classical bit there are two states. It's binary, it's either 1 or it is 0. But remember, in a quantum computer, how is data stored? It is stored in the form of qubits. Okay, it's also called as quantum bits. or they also sometimes write it as QUBITS. All these things, they mean one and the same thing. Okay, so they use qubits or quantum bits. Okay, so instead of the normal two states in a qubit, you will actually have three states. Okay, what are the three states? I will try to explain it to you in the next slide. Okay, so before that, before I explain you all the three states, I would like to give you a small example, because you need, when the concept of superposition first evolved, etc., it was very difficult for people working in the field of quantum physics to try to explain these things. And remember, Albert Einstein, right? He never liked quantum physics. You might have heard his very famous quote. It's called as, "God does not play dice with the universe." Why does he say that? Why? Because remember, dice is something that is associated with probabilities, right? You always have probability, 1 out of 6 of getting a 1 or 2 or anything. Dice is all about probabilities, right? He says God does not play probability with the universe. Why is this? Because as I told you, when I told you, tell me where is an electron, I told you, you would be able to tell me that with 89% probability, I can tell you electron is somewhere over here. So as you can see in quantum mechanics, we always deal in probabilities. And as I told you, Einstein never believed in, for a long period of time, he was a staunch opponent to the quantum physics, right? So that's the reason he actually comes up with this quote, God does not play dice with the universe, right? There's so much probability involved in this quantum mechanics. I don't believe on all these probabilities. That was what he meant to say. And later Stephen Hawking, he countered it. He says that God does play dice with the universe, and sometimes he throws the dice somewhere in the universe that you can't even find it. Okay. So anyway, coming back to our topic. So let me just give you a very simple example. Okay. So you have a box. Okay, let me draw it. This is an opaque box. Opaque box means it is not transparent, so you don't get to see what is happening inside this box. Okay. Imagine you have placed a cat over here. Okay. Assume this is a cat. I drawn it like a human, but assume there is a cat over here. Right. There is this glass vial. This glass contains poison. Okay. Let's take green color for some reason. Green. Okay. This is poison. Okay. There is a hammer-like system over here. Right. So what really I would like to tell you is that this hammer might fall, and this might break the glass. If the glass breaks, the poison will be released and the cat will die. Okay, so the falling of the hammer, it's something that is probabilistic. The hammer might fall, the hammer might not fall, but if the hammer falls, the glass will break, and if the glass breaks, the poisonous gas will come out and the cat will die out of poison. Okay, so as we can see, there are two scenarios. One is the glass breaks, which means you have a dead cat. Or the second scenario is glass doesn't break, in which case you have a cat that is alive. Okay, so these are the two scenarios you have. Either the glass breaks or the glass doesn't break. That means, in simple language, either the cat is dead or the cat is alive. And remember, this is happening inside a box, and as I told you, this is an opaque box. Opaque means something that is non-transparent, so that means I cannot see what exactly is happening inside the box. So I cannot say with 100% surety whether the cat is dead or alive. So at this point of time, before I open the box and actually find out what is really happening in the box, I see that the cat is neither dead nor alive. It's actually in a state of both dead and alive. Until and unless I open the box, I cannot prove either way. So before I open the box, the cat is both dead and alive at the same time. The poison glass vial is broken and not broken at the same time. Right? So you can ask me this question: how can something be in two different states at the same time? Right? How can the cat be both dead and alive? That is what exactly happens in quantum mechanics also. Remember, electron is also exhibiting this concept. It is called as superposition. So as you can see, the cat is both dead and alive. So it is a superposition of two states. Okay, it's a superposition of two states. Right. It's a superposition of two states. So that's what is happening over here. Also, I told you there are three states in quantum, in your quantum computers. You have electrons; they can be in state 1 or 0. or they can be in a superposition of one end, right? So they are in a superposition of one end. So these are the three states, and this kind of characteristic, it imparts the quantum computer its specialities, right? So these phenomena that is happening in the quantum world is what is imparting this kind of strange or odd behavior at the quantum state. Nevertheless, these things have a lot of applications. As I told you, we can do something at a faster rate. Right nowadays, for drug discovery, etc., we are dependent on something called as bioinformatics. We use computers for drug discovery, for coming up with a new drug or cure for coronavirus. So over there, now remember, if we start using quantum computers, it is going to yield you a lot of results. Okay. So that's what it can give you: enhanced storage capabilities, enhanced computational capabilities. It can give you faster communication, safer communication, etc. I will talk more about it in the future lessons. So before I leave, I would like to give you a food for thought, a very interesting example. Okay, so this was my project in IIT Delhi for a brief period of time. Okay, so I'm not giving you the exact details. Okay, I was working on something called as Deutsch-Rosa algorithm. So I'm not giving you the mathematical concept of behind it. I'm just going to give you a fair idea, a parallel I'm going to draw, so that you appreciate what exactly happens in this quantum world. Imagine I take 2 points, I flip them and I hide them, or you hide them in your hands like this. You're holding your hands. In one hand you have the coin, in the other hand you have another coin. So there are 2 coins. Now what do? You open one hand. Okay. So remember, in this case, it could be head head, head tail, tail heads, and tail tails. These are the four possibilities of the coins, right? You have closed both of them. I don't know what's happening. I don't know which state both of them are in. Now imagine what do? You open one hand and you show me. Let's for now assume that it is tails, right? That means there are still, I have not opened this hand. My right hand is still unopened. So there are two possibilities. It could be tail heads or it could be tail tails, right? So now the challenge is, without opening this hand, with 100% probability, you should tell me whether it is tail heads or tail tails. Right? Now you might ask me this question. There's a 50% probability that I would be wrong, but I'm telling you with 100% surety, you have to tell me that. Okay, can you really do that? So these kind of things, these kind of counterintuitive things are possible in the quantum world. Okay, so this is just to give you an interesting example, but what is more important for the examination, as I told you, is to understand what exactly is this quantum supremacy. The term sycamore is very important. It's a quantum computer. What exactly did it do? That also. What problem did it try to solve? That is important, right? It solved it in 200 seconds. What would have taken 10,000 years? The problem, that is, they are trying to find out, are random numbers generated by the computer truly random? That's what they are trying to get addressed. Then I told you a little bit about quantum mechanics. I told you about the difference between a classical computer and a quantum computer. And remember this term, it's called as qubit or a quantum bit. Okay. And then I told you about the concept of superposition, tunneling, etc. Alright. So this is all for now. So before I leave, I'd like to tell you about 3 mega batches that are starting with Unacademy very soon. That is from 15th June onwards. So it has started from 15th June onwards, right? So there are 3 batches for complete preparation. So this is for 2020 to 2021. As you can see, you have them. There's a bilingual course. There's one exclusively on English. There's one exclusively on Hindi, and these are all conducted by top educators in the country. And other than this, you can actually go for subscription if you want unlimited access to all these classes. Okay, and other than this, there is this UPSC Championship that is conducted regularly. This is completely free of cost. Okay, anybody can and everybody can register for this, and they can take this examination. They can also get an All India live score if you join this on these particular dates from 10 to 12, 10 a.m. to 12 p.m. Alright, the next one is going to be on 21st June, and these exams are curated by people, experienced people. For example, Amranal sir, Atish sir, Rakesh Umar sir, etc. So these people are the curators, so you can see the quality of the tests. It is very comparable to the real UPSC prelims examination. So make sure you're enrolling, and this is for free. So if your preparation is even like 50 to 60% complete, I would highly encourage you to go for these test series. Alright, and before leaving, so if you're joining Plus, you can use my subscription code, Plus code. It's called as AKM Siva. This will give you a 10% off on your Plus subscription, and also you can catch me live every day, nearly every day at 7 a.m. to 8 a.m. in my special classes. This is again completely free, but this you would only be able to access on the Unacademy platform. So make sure you create an account and then you join me live for these sessions. So that's all for now. Have a good day, and I will come up with more such videos in the future. Thank you so much and have a good day.